Hi, welcome back. So yesterday, you might recall that my phone kind of just blacked out on me, and then I got frustrated and decided to stop. And that's in part because I was continuing to draw and talk and put this thing together, and my phone wasn't actually on. So that was awesome. But today we have a different story. I'm going to give you guys a second or two, or maybe you could pause the video and just get caught up with where this picture is. So your picture left off somewhere right in here. So I wrote in the word lichens, I wrote in the word algae, and I built this little fungi branch, and I put 3 little plops on here. Interesting thing about fungi, as you may or may not know, is that there's no chloroplasts in fungi. Fungi are heterotrophic, and so they eat for a living. And there are some beautiful stories about how fungi work. I don't know that we'll actually have time for them, though. Maybe in a couple years when you hit AP biology, we'll find some time to talk about the fungi. But I just put in 3 major groups. I put in the mushrooms. I'm going to turn my page a little bit here so I can write the scientific name for mushrooms in this space here. And that is Basidiomycetes. I know, crazy, huh? B-A-C-I-D-O, Basidiomycetes. That's a T. So the Basidiomycetes is the mushrooms. And we could just draw a little mushroom right here to illustrate. They have this undercarriage that is called gills, and the gills produce spores, and those go on to reproduce new mushrooms. And yeah, so that's the Basidiomycetes. We also have a group called the Ascomycetes. A-S-C-O, Ascomycetes, and the Zygomycetes. Zygomycetes is a mold, and you're going to see a lot of that growing on your food. So probably when it comes to fungi that you're pretty darn familiar with in your kitchen, it's going to be the Zygomycetes. And this is just going to be a different kind of fungi here. So there we go. We've got 3 different ones. There's more, but I just wanted to limit it to a couple that you might want to look at. And over here, where we have this thing dividing out, what I want to do is create a branch that's going to go up. And I have over this way 3 branches. So I'm going to have 1, 2, and 3. And this guy here is going to represent so all of these here at this point are plants. Whoops, you can't see that. Plants. But then the plants have a big divider right away. There's the non-vascular plants. So we could say these are non-vascular. And what that means is they don't have a vascular system, like veins and arteries in your body that carry blood around. Plants have a vascular system that moves nutrition and water around. And so at this point, you either have vascular plants here, which is going to be this big branch that we're going to fill in, and the non-vascular. Now, why would you not need a vascular system if you were a plant? Well, the truth is that the plants that are non-vascular have to live in, on, or around water. And so when we look at the plant kingdom and we start with algae down here at the bottom, algae lives exclusively in water. And as you move away from water, because all living things began, whether you're a plant, an animal, or a fungi, there's a beginning that happens in water. And then as time moves on, this movement away from water is sort of this accumulation of traits that will allow you to live away from water. The non-vascular plants have to live on, in, or near water because they don't have a vascular system to carry water around. They can't get very large. So we would say the non-vascular plants with this early adaptation are the most primitive of plants. And I just am going to have 3 on here for you. We're going to have the liverworts. And you can find these locally. There are also the hornworts. I've never seen a hornwort locally. There might be some. I've just never seen one. And the mosses. I'm going to give myself more room here. The mosses. And of course, we have all seen mosses. We have them at the school. They grow kind of in the gutters and along the ceilings and on the ground. We see mosses everywhere. So I thought it might be kind of fun to just take in our drawing. I know, Tommy, you're going to like this. We're going to draw in one of each of these. Liverworts look like a little slab of skin that's green with little hairs on it even. And they grow, like I said, near water. So along a waterfall or a natural spring, any rocks that have natural water year round, you're gonna see these guys. And they have little parasols that grow out of them. And these little parasols produce spores that can go on and create more liverworts. And they have little collection areas on them called gemma cups. And they actually have sperm that swims through the water to find another liverwort and mate with it and produce more baby liverworts. So I think I'm going to try to attach a video on each of these so that you can, check them out. I have also hornworts that look just a lot like liverworts, but they're a different lineage. So I'm just going to draw them like that. And those again are spore producing areas of the hornwort. They don't have the little parasols though. These are really cute. You'll see them in the video. And of course the mosses. We're really familiar with mosses because we see them everywhere. One thing you probably didn't know about mosses that you might feel like you really need to know is that they have what's called, well, these guys do too, but an alternation of generations where, what does that mean? It means that, remember the words haploid and diploid. The plant itself is both haploid and diploid. So haploid, remember, it has half the chromosome number, and diploid means it has a full set of chromosomes. So when we look at mosses, this green leafy part that you look at and say, oh, that's a moss, that part is all haploid. And remember, in your body, the only cells that are haploid are your sperm and your eggs. So these moss live and grow, and they're multicellular in the haploid form, which is kind of cool. And then when they reach some level of growth or the season is right, this stalk begins to grow out of the top of them. And if you think about it, I'm sure you've seen these stalks before. You maybe haven't really thought about it, but the little stalks are the diploid part of the plant. So this, at the top of the green leafy area, a stalk will grow that has a full set of chromosomes. So fertilization must have occurred at some point, and this grows and produces a bunch of spores, and those spores can go on to become new baby mosses. And unless you look at the video, it's going to be hard to describe that unless you can see it. So I wish I was there to point at stuff and show you, but I'm not there. So we just have to make do with what we've got. Okay, so I wanted to take and color in this section green to represent the fact that these guys all have chloroplasts. And I wanted to, I wonder how far I should go today. It's always a question, how far to go. Yep, you know what I'm gonna do? I am going to tell you about lichens. I'm putting these in as brown because they do not have chloroplasts. These guys only have mitochondria because they're heterotrophs. Fungi are eaters. They eat for a living. They do not photosynthesize. So I've got my fungi, and I wanted you to see really quickly that there's this bridge that I put in here. And I know I've probably talked about this before. This is the lichens. Lichens are a fungi and an algae that live together in some kind of harmony. Lichens are very important as a pioneer species because what they do, lichens are I guess I could draw one like this kind of. Lichens are made of fungus on the outside. It's like a fungus house. And the fungus, as you know, fungus can be kind of tough. And these fungus grow on rocks. So imagine you have a boulder and it has grown little roots down into the boulder. And inside of this fungus house are algae. And the algae can photosynthesize. So what lichens do is they're able to absorb solar energy and use it to make ATP. And then the fungus is able to utilize that energy from the algae. So this is a symbiotic relationship where you have two different organisms living together to produce energy and survive with each other. So this is a true symbiotic relationship, one that's mutual between the two. The algae benefit from the fungus and the fungus benefit from the algae. And the other thing is with lichens produce soil. They're soil producers. And so when I put these little roots down into a rock, if these roots are able to dissolve and break apart the rock and create soil, and soil is absolutely essential for other organisms to start growing and living in an environment. So when it comes to, building a habitat, lichens play a major role because they produce the soil that allows slightly larger plants, maybe like moss, to be able to grow. And then as they produce more soil, then other larger things can grow and larger things can grow until eventually you end up with great big trees being able to live in an environment because there's soil for those trees to live in. And that is a topic for the next unit, ecology. And we'll talk about that more in the future. Pioneer species, lichens. Okay, I'm gonna leave it there. I'm gonna attach some videos of these organisms so you can see what they look like and what they do. And that should be a Google form to fill out, and you'll be all done for today. Have a good one.